So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme of trigonometry and Pythagoras by looking at some 3D trigonometry problems. Now, right angle triangles don't just exist on flat surfaces or planes, they also appear three-dimensionally. Now, often you'll be asked to find the length or angles inside a 3D shape and may need to use Pythagoras' theorem and or trigonometry to find these. So for example, if we look at the cuboid you can see on the screen, so if I look at this right angle triangle, so if I look at the flat surface of ABCD, then here I've got a right angle triangle. So I've got this side, I've got this side, I've got this side. I've also got this angle here, this angle which will be 90 degrees, and this angle here. Now if I looked at another rectangle, so let's have a look at this one here. So if I draw another right angle triangle, again I've got the sides of DC, DH and CH. And I've also got, although this angle here is 90 degrees, this angle here and this angle here. Now if I picked another triangle, which I can see from the top, so looking at the plane of AFED, I just pick this triangle here. Then this angle here would be my 90 degrees. This is a side, that's a side, that's a side. And I've also got these angles here. Now, that's looking at it from a two-dimensional perspective, but we can also look at a cuboid with it being a 3D shape, looking at it three-dimensionally. And what I mean by that is the fact that I've also got another right angle, and let's use this over here, whereas I've got one side which is BC, but then I'm going to connect it to H, and that in itself creates another right angle triangle where this angle here is 90 degrees. Then I've also got this angle and I've also got this angle here. Now I've also look at that, if I just get rid of that triangle so it doesn't merge with the next triangle. So if I look at this side here, I can also draw another right angle triangle connecting the line of, or the side of FG to C. And so this angle here is 90 degrees, and I've also got this angle here and this angle here. And so there are lots of different right angle triangles you can draw, particularly in the cuboid, but also many other 3D shapes. Now, finding these lengths or angles will involve finding a length or an angle that you're not asked to find, and we do this by using Pythagoras and trigonometry before finding out what you need to find. Now, the method that we do this, now although it's labeled as 3D trigonometry, you can also merge in with 3D Pythagoras, because when you're dealing with trigonometry, you're dealing with sides as well as angles in right angle triangles. And how can you find sides of a right angle triangle? Well, you can do that by using Pythagoras. Now, most 3D trigonometry problems can be resolved by looking at these 4 steps, although they are not set in stone for every single question that you could get asked. Now, the first step is to identify the right angle triangle that includes the required information. And that, what I mean by that is what is being asked. Now, I don't want to use the letter X, but it's always good to try and label what it is you're actually trying to find as a final outcome as X if it's not been done for you already, which I'll be honest, never really is. The next thing you want to do is redraw the triangle as a separate right angle triangle. So you want to take that right angle triangle out of the 3D shape so that you're just dealing with a 2D model. And you want to label the given information and the information found. Often you'll be missing another length or angle on this triangle, otherwise it wouldn't be classed as 3D. Now the next step is then to find another right angle triangle whereby you have either 2 sides, so you can then use Pythagoras, or a side and an angle where you can use trigonometry. And this will enable you to find the side or the angle required that you need to find in step 2. And then step 4 is then solve the problem and round to a suitable degree of accuracy. Now again, when you translate anything into words, particularly when it's involving a diagram, it's always going to be extra complicated. So hopefully, if you're not too sure about what these 4 steps mean, hopefully they will make sense when we look at some example questions. So looking at this first question, so here we've got a cuboid and the question is asking us to find out certain lengths and angles. So this question says the diagram shows a 3 by 5 by 4 centimeter cuboid, and the first part it's asking us to find is AC. So looking at the side of AC, now what I'm going to do is I'm just going to highlight the length of AC, which is what I'm trying to find. And what I'm going to do is I'm going to redraw. I can see a right angle triangle that uses X, and I'm going to take that out. So here for part A, I'm going to redraw the triangle, and I've got A, B, and C, and labeling the sides I've got 3 centimeters, 5 centimeters, and X is what I'm trying to find. Now, in terms of, like for example, if you were to draw another right angle triangle that uses AC, you may have selected this triangle here. Now, if I use that triangle there, which is DAC, and that's my 90-degree angle, this side is 4, but the problem is that that is the only information I know to work that out. And obviously, in order for me to find a side, I either need to know what the other 2 sides are to use Pythagoras, or I need to know what an angle is involved in that right angle triangle, which in this case I do not know. So I can't use that right angle triangle. So it kind of becomes pointless. So going back to what I can do, which is using this triangle here. So what I've got is that x squared equals 5 squared plus 3 squared. And then working that out, I've got 25 plus 9 equals x squared. So x squared equals, it's going to be 34. So x equals the square root of 34, which on the calculator gives me an answer of, if it was a calculator question, which we'll just assume that it is, and that gives me an answer of 5.83. And that's to 2 decimal places. Then working with B, now if I kind of look at this, so it says find the angle ACD. Now angle ACD, if I just get rid of all of this. Now what I definitely do encourage my students to do is to have coloured pens. Now although coloured pens are kind of frowned upon in exams because they scan your papers in, as long as you're not using a coloured pen for anything that you want marked, you can use it. So just be wary of that. And obviously, so if you want to take in highlighters in the exam, that's fine. But just note that anything that you use that's not in black or blue ink, as recommended on the front of your exam paper, will not be marked. So just be mindful of that. But when it comes to 3D trigonometry or Pythagoras questions, coloured pens are going to be like a best friend. So looking at this, then we're trying to find the angle of ACD, which this question has conveniently highlighted for me. So this angle here now is my X. So using that triangle, which is dashed, so for B, I've got this triangle here. And this is my angle X, this is D, this is A, and this is C. Now in the question it's told me that this length here is 4 centimeters, and in the previous question I know that the length of A to C is root 34. Now the reason why I'm using root 34 is because I want to try and keep the answer, or that length, as accurate as possible. Now I could use 5.83, which would be absolutely fine because I've kind of used a few more extra decimal points. But if you want to be super accurate, then try and use the exact answer. So from this is where I've got 2 sides I'm working out an angle. So label the sides. So this is going to be my opposite. This is going to be my adjacent. So I'm going to be using tan. So here I've got tan x equals the opposite, which is 4 over root 34. So therefore then I've got that the inverse tan of 4 over root 34 equals x. So x then equals, or the angle ACD is going to be the inverse tan. If I type this into my calculator, 4 divided by root 34, it gives me an answer of 34.4, which does look correct. So 34.4 degrees, and I'm going to round that off to 1 decimal place. Now if I used 5.8 or 5.83, I should still get an answer that's close to 34.4, but 34.4 is probably the most accurate answer you can get. So as long as your answer is close to that number, you're going to be absolutely fine. And you can see that by drawing separate triangles just makes your life just so much easier and makes the question that little bit more understandable. Moving on to question 2, it says the diagram shows a wedge of A, B, C, D, E, F. The base of the wedge is a horizontal rectangle measuring 60 by 40. The slope face, which is A, B, E, F, makes an angle of 25 degrees to the horizontal. And the question is asking us to calculate the length of AF. Now, AF is the longest side that, if you were to imagine that this was a box, the longest length that could fit, or stick that could fit in this, is going to be A to F. Now, to work out, to turn that into a right angle triangle, so if I just label this as X, then this is the triangle that I'm working with. So here I've got, let me just do that triangle here. So this is X, and this is A, that is F, and that is C. Now in this current time, I have absolutely no idea on what any of the other lengths are, so that's what I need to find. I need to find A to C, or I need to find F to C, any of those two, so they can use Pythagoras to work this out. Or I could work out what one of the angles are to then work out what X is, but I think the angle is going to be a little bit more difficult to do. So let's look at finding A to C. Now if I then discover another right angle triangle, so here I've got this right angle triangle I could use to find F to C. So let's do that first. So looking at this triangle here, I've got F to C, I've got this is 25 and this is 60. Then labeling the triangle, let's just call this X. And so, well, let's call it a different letter because I don't want to get confused. So let's call it Y. So here from this, I've got, I'm going to use tan again. So it's tan 25 equals Y over 60. So Y equals 60 times tan 25. So from this, then I can then work that out. So 60 tan 25 gives me an answer of 27.978, and that continues. So this length here, what I've then found is 27.978. So the next thing for me then to then find is to try and find another right angle triangle. So this time let's use this triangle. I probably shouldn't have gone for orange, so let's use a different color so it doesn't clash. Let's use this light blue. Let's go for this triangle. So using that triangle and just labeling it up, I've got A, C, B, and this length is 40 and this length is 60. So to find A to C, I can use Pythagoras, and let's call this Z. Now it doesn't matter what your letters are called, so basically Z squared equals 60 squared plus 40 squared. So Z squared equals 60 squared plus 40 squared equals 5,200. So Z equals the square root of 5,200, which gives me an answer of 72.111. So I can then label this as 72.111. Now the question is asking me to find the length AF. So now I've got two sides. I can now work with that initial triangle that I drew. Then using this and labeling the sides, I've got that X squared equals 27.978 squared plus 72.111 squared. And so then typing that all into my calculator, I've got 27.978 squared plus 72.111 squared equals, and that's going to equal 5982.76. And then if I then square root that answer, I get an answer of 77.348. So then the answer to AF is going to be 77.3 centimeters, and that's to one decimal place. So it says 3 sig fig, but it's still the same. So let's just label that, and that's to 3SF. Moving on to question 3, it says that the diagram shows a 12 by 3 by 4 cuboid, and the question is asking us to find the angle of GEC. So again, the first thing you want to do is to find what that is. So G to E to C. So it's going to be looking at this angle here. So if I just take that triangle out, and so this is G, C, this is G, this is E. Now from that triangle, I know absolutely no lengths of that at all, but this is the angle that I need to find. So let's just call that X. So I need to find what E to G is and C to G is, or find out what E to C is. I need to find two sides of that right angle blue triangle. So looking at this, then if I can see that this here makes a triangle with two sides that I know. So this triangle here, which is E, H, and G. This length here is 3, this length here is 12, and this length here is, let's just call that A. So using Pythagoras, I've got A squared equals, and it's going to be 12 squared plus 3 squared. Now using Pythagoras, I probably shouldn't have used A. Let's just quickly change that. Not that it makes an absolute smidgen of difference. Let's just call that D squared. And then typing that in, I get D squared equals 12 squared plus 3 squared equals 153. So D equals the square root of 153. So from my blue triangle, I can label this side as the square root of 153. Now, from this, what I can then do is I then need to find another side. Well, actually, I know that this side here is 4 centimeters, because if this is 4, that's going to be 4. So then from this, I can then work out what angle X is going to be. So from this, I can then label this triangle up. So this is the opposite, this is the adjacent, and so I'm going to use tan. So I've got tan X equals 4 over the square root of 153. So X equals the inverse tan of 4 over root 153. Now if you were to use the decimal equivalent of root 153, again, absolutely fine. I'm just going for the most accurate answer as possible, but to be fair, it may not even make a difference to your final answer. So from this, I get an answer of 17.9 degrees, and that's to 1 decimal place. And moving on to question 4. So this time we've got a square-based pyramid. And the question saying that the diagram shows a 9 centimeters by 7 rectangular base pyramid. All the diagonal sides, TA, TB, TC, and TD, are lengths of 12 centimeters, and M is the midpoint of the rectangular base. Work out the angle of TAC to 1 decimal place. Now TAC, if I just join this up, so let's get a blue pen to keep it consistent. So it's this angle here that I'm trying to find. So if I just take that triangle out, and I've got A, T, and M. This is the angle that I'm trying to find, so let's just call that X. Now, looking at the diagram, do I know any sides of that triangle? Well, I do know that that length there is 12. But I don't know what TM is, I don't know what AM is, so that's what I need to find first. I need to find one of those lengths. So looking at this, what I can see is another right angle triangle, which is this red triangle here, that involves A and M. So looking at that red triangle, I've got A to C to B. This is 9, this is 7. And this, let's just call that M. So from this, using Pythagoras, what we've got is we've got M squared equals 9 squared plus 7 squared. So M squared equals 81 plus 49, which is 130. So M equals 130, and again I probably should not have used M, so let's just quickly change the reason for that, because M's already been used. Let's just call it P. So if P squared equals 130, then P is going to equal root 130. Now A to M is half of this, so therefore A to M is going to be root 130 divided by 2. So this length here is root 130 divided by 2. Now again, if you want to use a decimal equivalent, because you don't really want to go through that, divided by 2, you should have an answer of around about 5.7. And so instead of using root 130 over 2, we can use 5.7 instead if you feel that's more comfortable to work with. So from this, what I can then do is label this triangle. So this is my H, this is the adjacent. So I'm going to use cos, so cos x equals 5.7 divided by 12. So the inverse cos of 5.7 over 12 equals x. And so if I then type that all into my calculator, 5.7 divided by 12, and it gives me an angle of around about 61.6 degrees. And there is my final answer. Moving on to question 5, it says the diagram shows a wedge, very similar to question 2. So it shows a wedge of A, B, C, D, E, F. The base of the wedge is a horizontal rectangle measuring 70 by 50 centimeters. The sloping face ABEF makes an angle of 30 degrees to the horizontal. And the question is asking me to calculate the angle that AF makes with the horizontal plane ABCD, giving your answer correct to 3 significant figures. So what this question is asking me to find is basically this angle here. So let me just quickly draw that triangle out. And so I've got A, F, and C. And then all I then need to do is see to myself, do I know any of these sides? And at the moment, no, I do not. So I need to find what A to C is, and I need to know what F to C is. So from this, what I'm going to do is try and find a decent colour pen. So let's look at this triangle here. So this side uses F and C. So drawing that out, F to C, and let's just call this H. No, let's not call it H. Let's call this N. And we've got this angle here, which is 30, and I've not labelled that point, which is B. And we also know that this length here is 50. So to work out what N is, I've got to use trigonometry. So again, it's using tan. So I've got tan 30 equals N over 50. So N equals tan 30 multiplied by 50. And if I type that into my calculator, times 50. Now make sure if you're using a Casio calculator and you're using it the way that I've written it on the screen, make sure you put in a bracket around that 30. So it looks like that. And you should have an N value of 28.8675. So from this, what I've then worked out is F to C, so I can cross that out and relabel this as 28.8675. The next thing for me then to find is what A to C is. So again, if I draw another triangle, so let's go for this triangle here, and let's do that over here, and that's probably a really bad right angle triangle, so let's try that again. A little bit better. So we've got 70, we've got 50, and this length here is my A to C, which we're going to call P. So from this, I've got to use Pythagoras because I don't know any of the angles. So P squared equals 50 squared plus 70 squared. So P squared equals, and again on the calculator, 50 squared plus 70 squared equals 7,400. So P equals the square root of 7,400, which as a decimal gives me 86.0232. So this length here now is 86.0232. Now again, what I've then got to use is, now I know what two sides are, I can now go on to work this out. Labeling the triangle, this is O, this is A, so I'm going to use tan. So I've got tan x equals 28.8675 divided by 86.0232. And so if I write in, so x equals the inverse tan of 28.8675 over 86.0232. I get an answer of, and let's just quickly type that in. I get an answer of 18 point, and I want to round it to 3 sig fig, so it's going to be 18.6 degrees. Then moving on to our last example. So we've got Sue has a crate open at the top, and it says in the shape of the cuboid, the internal dimensions of the crate are 36 centimeters long by 36 by 60 centimeters. Sue has a stick of length of 90 centimeters. She places a stick in the crate so that the shortest possible length exceeds outside the top of the crate. And the question is asking, calculate the length of the stick that extends out of the crate. So let's kind of have a visualization of what it is. Now, the longest length of a cuboid is going from one bottom corner to the opposite top corner. So this length here is the longest length. Now, Sue has got a stick that extends out, and what this first part of the question is asking is, what is this length here going to be? Now, in order for me to find that, I need to work out what that diagonal length line is going to be. So from this, so if I just highlight this in colors, so this is the green bit is the answer that I want, but I need to know, and the whole length of this is 90. So I need to work out what this length here is. So from that, what we then need to do is just get rid of all of this, so we can work with what we're working with. So this is the bit that I need. Let me just draw that as a right angle triangle. And let's call that X. And let's call this Y. And I know that this length here is going to be 60 centimeters. I know what one of the sides of that triangle is, so I need to find out Y first. So looking at this and label this in as Y, I've got 36 and I've got 36. So y squared equals 36 squared plus 36 squared. So y squared equals, and again reaching for my calculator, 36 squared plus 36 squared equals 2592. So y equals the square root of 2592. So what I can then do is rub out y and label that as 2592. So then if I then take that green triangle out, let's actually use green. I know that this length is 60. This length is what I'm trying to find. And this length here is square root of 2592. So x squared equals 60 squared plus the square root of 2592 squared. And typing that all into my calculator, I get 6192. So x equals the square root of 6192. Then from this, the length left, so the answer is, so if this length here is the square root of 6192, then I need to take that away from 90. So 90 centimeters, take away the square root of 6192 equals, so 90 minus square root of 6192 equals, it gives me an answer of 11.3 centimeters to 1 sig fig, or 3 sig fig, sorry, or 1 decimal place. Now, moving on to question B, it says calculate the angle that the stick makes with the base of the crate. So basically, going back to this question, it's asking me to work out what this angle here is. So if I just call that B, so this is the angle answer for A. So then B, using this triangle then, I'm going to use trigonometry. So I'm using tan again. So tan B equals 60 divided by the square root of 2312. And from that, or 2192 should be, and I don't know what I've put. that there, so 2592. And what we then get is that b equals the inverse tan of 60 over root 2592. And if I type that into my calculator now, I get an answer for an angle of c divided by 252 of 49.7. Again, that is to 1 decimal place or 3 significant figures. And there we go.